Hello, today we're going to talk about creating equations. Alright, this lesson involves systems and basically their graphs. So there's three ways it's going to look when you graph a system. So a system is two equations that are together. So when you graph a system, so it'd be like y equals 2x plus 5 and y equals 3x minus 6. This is a system of equations. It's two equations together that have different forms of solutions, usually only one. So this will look in three ways. So the first way is what I just showed you. Let me do a different color so it looks better. So two linear functions and they cross at one point. The point that they cross is the answer. This is called a one solution. All right, when you have one solution, the lines only cross at one point. An example of this would be y equals negative 3x plus 10, and then y equals 2x plus 2. All right? They're two equations. They don't match up with these lines, so don't try it. They're two linear equations that have one solution. So if I solve this out, they would have one solution somewhere. All right? The next way it could turn out is no solution. So if you graph a system of equations and you get two lines that look like this, those lines are parallel, right? They'll never touch. They go forever and ever one direction or the other. An example of this would be y equals x minus 1 and y equals x plus 2. All right? So when you have two parallel lines, the slope will always be the same. So anytime you have the same slope and different y-intercepts, you have a no solution. They'll never touch because they're going at the same rate of change forever and ever. They just go through the y-intercept at different points. So that's a no solution. And the last one is infinite solutions. And that is when, I need my colors for this. You have two lines that are on top of each other. Forever and ever, they go the same place for all time. That means they're the same exact equation. All right, so when you solve it out, if you get the same exact equation, it's the same line in both of the equations. That's infinite solutions, or all real numbers. All right? All right, example number 1. All right. This is not in slope-intercept form. Anytime you graph a line, you always want it in slope-intercept form, which you have the y on one side and the slope and the y-intercept on the other side. So I'm going to change both of these to make them into slope-intercept form. This one, I just need to subtract the x from both sides. Same thing here first. So negative y equals negative x plus 0. Then divide by negative 1, so y equals x. All right. So I can graph this if I really want to, and then this will be the only one I actually graph to show you. All right, so if I'm going to graph this one, my y-intercept's at 4, and my slope is negative 1. Graphed. All right, so then I just have x, so my y-intercept's at 0, because it's actually a plus 0 back there. I just got rid of it here, and it's positive. So what is that? That is a one solution problem. Wherever those two cross is an answer. Example 2. So x plus y equals 7, and x plus y equals 5. Again, I gotta solve to make them look like their slope-intercept form. So negative x plus y equals 7, nope, equals negative x plus 7. Y equals negative x plus 5. Alright? So if you remember the way it looked before and what I told you, these two have the same exact slope. I'll graph it again just for the fun of it. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 1, 2, 3. Alright, so I'm going to graph this first one. My y-intercept's at 7, and it's a negative 1 slope. So I go down 1, over 1. Now this one, its y-intercept's at 5. My slope is negative 1, so down 1 over 1, rise over 1. Alright, so this is a no solution. They have the same slope but different y-intercepts, so they're going to go forever and ever parallel to each other for all time. So again, once you have one that have the same slope but different y-intercepts, there's no solution. Alright, example number 3. Got to put them in slope-intercept form. So minus 2x, minus 2x. So I get negative y equals negative 2x plus 7. Divide by negative 1, divide by negative 1. Y equals 2x minus 7. Then my other equation was 2y equals 4x minus 14. Divide by 2, divide by 2. Y is 2x minus 7. We have the same exact equation, so when we graph them, they'll lay right over the top of each other. So it'll be every number that ever existed, so it's infinite. Alright, now we're going to find what the solution is for these two. So this is already in y-intercept form. We're going to switch this one to y-intercept form now. Alright, there's two ways to do this. I can't graph accurately enough to do it. Yeah, by no means can I graph accurately, but you can graph them if you want. I'll solve it the way you're supposed to solve it, then I'll graph it to show you. So, take that out. So it's these two. So since y equals this and y equals this, so that means you can equal them to each other and solve. This is just simple. So x equals negative 1. Take that negative 1, plug it back in right there. So y equals negative 1 plus 6. Y equals 5. So our answer is negative 1, 5. That's how you solve. That's substitution. A form of substitution, I guess. So let me graph it just to see if I'm kind of close to the right answer. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going to graph this bottom one in blue. So I start at 1, 4, over 1. And we'll graph the top one. 1, 2, 3, 4, 5, 6. Start here. So they should actually meet right there. So if I curve this line a little bit like it's supposed to be. There we go. Close enough. But that's what it would look like if you were graphing it. Alright, this has been Create Equations 2. Hope it helped and good luck.